homogeneous functions. Now, the word homo means same. It originates from Greek, and genius also is of Greek origin. It means nature or type or kind. So homogeneous, the same kind. Now let's look at it in the context of the homogeneous function. A function is homogeneous the function, let me note, is the form of the function f of x, y, function of x and y is said to be homogeneous in x and y of degree n if for some scalar, this means some number, say lambda, our number is lambda, f of lambda x comma lambda y is equal to lambda raised to the n of f of x, y. So what happened here? You have a function in x and y, right? Now if you take x and multiply by a number, and you take y and multiply by that number as well, you work it out so that you can have that number raised to a power multiply by the original function f of x and y. Then it is homogeneous. What that means? This number raised to the power, it is a factor, same factor, homo part of the word same factor, of or throughout the entire function, right? Now here it has the same factor throughout the entire function. Now here genius, the kind or origin. So the word here refers to the fact, one way to think about it is that each part, the x and the y part of the function, they have the same factor, common factor. There is uniformity in terms of having this common factor throughout the function and the different parts of the function. Alright? Now, let's look at a few examples and see how we deal with this issue. Suppose we look at this function f of x, y is equal to x squared plus y squared divided by x minus y. Is that function homogeneous? Well, we can test it. We have, suppose we multiply x by a certain number and y by a certain number. Well, not a certain number, but some representative of a number, lambda. Alright? So we want to find f times of lambda x, comma, lambda y. What is it? Well, we would change x to lambda x. So we have lambda x, all of it squared, just like what you have up here, plus, instead of y squared, now we're going to have lambda y, all squared, divided by lambda x minus lambda y. Okay, with the next thing is to see if we can make changes to this so that we have some lambda. Could be lambda raised to a power, lambda square, lambda cube, whatever the case is, multiplied by all of this. How about you pausing the video and try it and see? Okay, you finished? So let's continue. This is lambda squared x squared plus lambda squared y squared divided by lambda x minus lambda y. Now, what do we have here? Can we factorize anything? Oh, lambda squared is a common factor here. So we put lambda squared outside a bracket. Inside the bracket we have x squared plus y squared divided by, what's the common factor? It is lambda. Common factor down here is lambda, so it's lambda times x minus y. Okay. Now what can we do with this? Well, you see here, lambda squared divided by lambda is lambda. So it's lambda times x squared plus y squared divided by x minus y. Let's compare this to what we have up here. F of x was x squared plus y squared over x minus y. But f of x lambda x lambda y is lambda times x squared plus y squared over x minus y. Alright. So, here, this is f of lambda x lambda y. It is equal to lambda raised to the power of 1 times the original function. So we can write f of lambda x lambda y is equal to lambda to the power of 1 times f of x y. So this function, it is a homogeneous function of degree 1.